Hello everyone, Sir Fredrick Mlenga here. So today in this video we are going to discuss Hooke's law. We are going to understand the important terminologies and the basic concept for Hooke's law. So let's get started. What is the basic concept just behind Hooke's law? So let's imagine we have a spring or any elastic material just right here. If this is our spring without putting anything, okay, so this spring has got a length, okay, that's got the length which we are going to call original length. We're going to call it original length, or maybe we can simply call it length x. Okay, but when you get something, you get that spring, you add a mass to it, it tends to increase its length. Suppose you put just a mass right there, maybe you can say 2 kg, it tends to increase the length. Or when just you stretch it, it tends to increase the length. Okay, so we are going to call this length as a new length. New length. So Hooke's law are the basic concept to say when you have a spring and you apply force to it, it stretches out. So that force you apply is direct proportion to an extension of the spring. So basically this is what Hooke's law dwell on it. So the force that you apply is direct proportion to what? To the extension of the spring. So this is basically what they all about it. Now let's define certain terminologies that we use under Hooke's law. So we'll start with the first one. So we have terminology. So the first one is actually elastic material. So what is elastic material? It's actually any substance which regains its original shape or size when the force applied to it has been removed. So examples of such one or such substances, there's a spring is one of them, and the rubber is also one of them. So these materials can be called elastic material. Why? Because they are able to regain, or they have the ability to regain their original shape or size when the force that is stretching them are removed. Then we have another term that we use. This is elasticity. Elasticity. This is what is this then? This is the ability of any elastic material or a deformed material to return to its original shape and size when the force causing it to deform has been removed. So the ability or the behavior of any elastic material to regain its original shape and size after you removed the force is what we are calling elasticity. So elasticity is the ability or behavior, while elastic material is the actual material that is being stretched. Then we have another term which we call, this is actually called elastic limit. Elastic limit. So if you have a spring and you apply force to it and it stretches to some point, definitely if you haven't added any force or you haven't increased any force, it is going to have a certain limit which it will stop. Okay. And this position or maximum position where this elastic material will reach and can able to go back to its original position or shape, this is what we call elastic limit. Some books they call it limit of proportionality. So in simple terms, if we define it, this is a maximum force that can be applied to a spring without stretching it permanently, or this could be the furthest point that a stretched material can go and return to its original shape and size. That's a elastic limit or limit of proportionality. Now, sometimes you tend to exert more force to a material or a spring such that it can undergo deformation. When you stretch it and you increase, you stretch it more than to its elastic limit and it never go back to its original shape and size, just know that you've destroyed that spring. And in physics, meaning you've deformed it, it has reached the state which we call inelastic. So this is just actually the deformation of a spring after you exert more force, or after it has reached its elastic limit and you extend it beyond that. Now, what other terms should we be interested to understand before we go any further? There is what we call original length, which is also a neutral length. As I said earlier, the original length is actually just the length of the spring without putting anything. That's why some books they call it a neutral length. So original length is actually the length of the spring before it has been extended or been stretched. Okay, some books they use x1 to represent the original length. Then some books they will use small l with a small o there to represent the original length of the spring. Okay, then the new length. What is a new length? So new length is actually the length that a spring obtains after putting a force to it, or the length the spring reaches when it is stretched. So in this scenario 1 and 2, if we have the same spring, then we put some force there, it's going to extend and obtain new length. So this length now, this length is what we call new length. Some books they use x2 to represent new length, or just the other length 2 to represent the new length. So what is new length? This is the length that the spring reaches when you stretch it. Okay, then we have extension now. What is extension? Most books abbreviate it with the symbol of capital E. So if you want to understand this one, let's do this. So let's imagine we have the first length, which is of the first length of this spring. Maybe let's put 2 centimeter as our first length. Then after stretching it, we obtain the new length of maybe 5 centimeter. So if we subtract x2 minus x1, we are going to have 5 minus 2. This will give us 3 centimeters. So this is the difference. So 3 centimeters is the difference between original length and the new length. And this is what we call extension. So extension in simple term is the difference between new length and the original length. And what is the formula? The formula is extension is equal to new length minus original length. So you'll find most book abbreviating it as extension is equal to x2, which is new length, minus x1. Or you can also find them writing like this: length 2 minus length or original length. This is the same thing. You still calculate your extension. Now, as I said earlier, Hooke's law. Then what does this law says? So Hooke's law states that the extension of the spring is direct proportion to the force stretching it, provided you don't exceed the elastic limit. Okay, so using the formula, we can say extension. Okay, so mathematically we can present Hooke's law by saying force is direct proportion to extension, where k shall mean constant. So mathematically then it can go like this: is equal to E then k. If you want to make k as a subject of the formula, we'll divide both sides by E. Then we're gonna have the constant is equal to force over extension. So now some books, because we understand that force can be load as well. So some books, they'll present the same formula as load over extension. Okay, so actually try to use capital E so that you are not confusing with the effort under simple machines. Okay, then let us do some of the examples so that we understand how far we can go with the problem solving. So for examples, so if we have these springs that we have, let me just increase the size so that we see them. Okay, so if we have that spring, Okay, so definitely we have the distance from this up to here. Okay, so this is going to be our distance 1 or original length. So our x1. Then let's imagine this is 12 centimeter. Then we also have the second spring which we added, force, and this becomes, let's put 14 centimeter, and this will be our new length. That will be our new length, so we'll abbreviate it as that. Then let's imagine this force applied here, the force in this rod which is there, let's say 20 Newton. Then the question is, calculate the extension of the spring. Then B, calculate the spring constant. So our solution will be as follows. So first of all, I always advise my student to correct what you have, which we call variables or data. Okay, so our original length is actually 12 centimeter. Then our new length, we had 14 centimeter. Then what are we looking for? Extension. We don't know. So extension is equal to new length minus original length. So extension is equal to 14 minus 12, and this gives us what? This gives us 2 centimeter. So this is our extension, implying that the 20 Newton force was extending the spring up to 2 centimeter. All right. Then what will be our constant? Then let's go to B. So we'll correct what we have. So from the formula we know that it is constant is equal to force over extension. So what we have is that we have extension of 2 centimeter, and we have the force. This force is how much? Is 20 Newton. Then what are we looking for? Constant, spring constant. So constant is equal to 20 Newton over 2. This is gonna give us 10 Newton. Just like that. Okay, so let's do another question. So this was fetched from one of the exam question paper in 2022. Says the following diagram shows an stretched spring of 10 centimeter and a stretched spring of 22 centimeter when a force of 4 Newton is applied. Calculate the total length of the spring when a force of 6 Newton is applied. So the first principle that you do here, you first find the extension of this 4 Newton. How much was this 4 Newton extending the spring? So we know that extension is equal to, let me use abbreviations. So extension is equal to new length minus original length. Okay, so the original length from the diagram is 10 centimeters, so we didn't have anything there applied. So original length was 10 centimeters. Then what was length 2 after putting a force? It went up to 22 centimeters. So extension is equal to 22 minus 10. So extension is gonna be 12 centimeter. This was the extension. So this means that 4 Newton of force or load was extending the spring up to 12 centimeter. Okay, then they have said calculate the total length of the spring when force of 6 Newton is applied. So if 4 Newton was extending the spring to 12 centimeter, how much will be 6 Newton? We'll put x there, then we do cross multiplication. X times 4, we are going to have 4x is equal to 6 times 12. What do we get? So get your calculator and punch this on your calculator. This will give me 72. So we divide that into that. So the extension of 6 Newton is going to be 18 centimeter. This will be the extension of 6 Newton. Okay. So this is how we handle questions. Now let's have one question that involves of doing more concepts, a lot of arithmetics. So in these questions, they have given us the extension in millimeters. Okay, so what we'll do first, we'll deal with the millimeters that we have. Why? Because constant is in Newton per meter, so we are going to do that. So let's correct data for A. So constant is equal to force over extension. So our extension is 2 millimeters. So we do well know that 1000 millimeters gives us 1 meter. What of 2 millimeters? What do we get? Cross multiplication, that give us 1000 x, then that gives us 2. So we want to remain with x, so divide both sides by 1000. That gives us 0.002 meter. So this is our extension. So spring constant will be, which we already know that our force given is 4 Newton. So 4 over 0.02. What do we get? 4 divided by 0. the constant of the spring was 2000 Newton per meter. Okay, so that's how we deal with A. Then B, what are we going to do with B? First of all, we have not been given force, we were given mass. So if we correct the data, mass given is 200 grams. Then extension given is 4 centimeter. So what do we do? First, we find the weight of this. We convert 200 grams into kg. So we know that 1000 grams gives us 1 kg. What of 200 grams? What do we get? Cross multiplication. That will still give us 1000x and 200 grams. So we'll divide both sides by that. So that 0 goes with that, that goes with that. So x is equal to this will give me, if you punch that, it's going to give you 0.2 kg. Okay, so now you found the mass, you've converted your mass into kg. What is remaining? You have to look for a force now. What was this force of this to 0.2 kg? So force is an example of weight. So you can simply use this formula. Weight is equal to mass times gravitation strength. Or rather, just put F there, then mass times gravity. So force is equal to 0.2 kg times times gravitation strength of 10. So this will give us how much? This will give us force of 2 Newton. Then we are good to go, because you have now force. Then you can able to look for spring constant. Spring constant is equal to that over extension. So my force is 2, then over the extension of what? Of 4 centimeter. Okay, so don't forget we had 4 centimeters, so that 4 centimeter will also still convert it. So 4 centimeter, so 100 centimeters gives us 1 meter. So what of 4 centimeters? What do we get? Cross multiplication, that gives us that 4. If you divide both sides by 100, it's going to give you how much? It gives me 0.044 meters. Then I'm good to go. So I'll pick that and use it there as extension 0.4. So extension 2 divided by 0.04. This will give me 50 Newton per meter. Okay, that's how you're supposed to handle these questions of this nature. So next time we will look at, in the episode 2, we'll look at the how can the graphing part of Hooke's law. How can we write a graph and interpret it? So thank you for your time.